everyone. Thanks so much for having me today. Having us today. Actually, there's several of us from the program, but
Sorry, I broke it. There we go.
So it's nice to see you all again, and be joined by some of my colleagues. Rebecca Belosa will be presenting after me, and then we have some support. Kathleen, some of you have met. Me, the Department of Public Health, and then Lily, who is at the Office of Environmental Hazard Assessment, you know. And just to remind everybody, I am from the Department of Public Health. I work on the Biomonitoring of California program, which is a collaboration between our department and OEHA and the Department of Toxic Substances Control. And I'll be giving an overview of biomonitoring today and give an example of a community-based study we've done, and then I'll pass it over to Rebecca, and we'll talk about biomonitoring studies that have been done in 8617 communities that are overburdened by air pollution. So what I'll be covering is, next slide please. I'm not used to having someone do this, it's very fancy. Okay. First I'm going to back up just a little bit and talk about environmental exposures to chemicals, like where those come from, how that happens, and then biomonitoring as a tool to measure those exposures. I'll talk about how and why we do studies using the example of a community study called ACE, the Asian Pacific Islander Community Exposure Project, and then I'll just talk about how what we learn can make an impact. So first, a little bit about environmental exposures to chemicals. Next slide, please. So we are exposed every day to just thousands of chemicals in our environments. They can happen anywhere and at any time, at home, at work, outside. There's air pollution, as you all know very well. Air, traffic, smoking, if you're smoking or you're exposed to secondhand smoke. Products that we, choose to use, put on our bodies, have chemicals in the things that we eat, including, fish that we might catch locally, jobs that we do, hobbies, work we do around the house. All these are all, even, our drinking water. We can be exposed to chemicals just living our lives. This is just like a fact of modern life. We can't avoid them. So, thank you, Lily. So we've got all these different sources of chemical exposures in our lives, but how do they actually get into us? So there are three major ways or exposure pathways that they get into us, and it can be through inhalation, so breathing in, PM, which you are very familiar with, dust, particles, fumes can be breathed in. You can also eat things, it could be that a food has something intentionally added to it as a preservative or a pesticide. Or it could just be something that's on your hands from touching different things and putting your hands in your mouth like kids do a lot. So kids actually get really exposed to this hand-to-mouth behavior, crawling on the ground and then sticking their hands in their mouth. So you eat chemicals, and then you can also absorb them through your skin. So putting something on your skin, or just touching something, or sitting in your shorts on your couch, chemicals just might get in through being absorbed through your skin. So also it's called a dermal exposure. So next slide, please. Yeah, it got kind of loose. So we're exposed to all these chemicals. They're getting into our bodies. They're how do we know how much we're being exposed to them? We do have a handy tool, which is called biomonitoring. Next slide, please. And this is the measurement of a chemical substance in biological material, usually for the purpose of monitoring exposure to chemicals. So we can collect usually blood or urine samples. There's also other, hair and other things, and we can measure chemicals that are in them. So, next graphic slide, please. So back to this sort of exposure graphic. The handy thing about biomonitoring is when you measure a chemical in a person's sample, you can see their total exposure to that chemical from all different sources, right? So it's just a good way to get just an overall measure of exposure to chemicals that are found in our, our environment, in the air and water and soil and dust and consumer products like furniture and personal care products. So some of the chemicals that are commonly biomonitored are metals. It's a group of naturally occurring chemicals that, just because they're natural doesn't mean that they're safe. So there's lead, I'm sure people have heard about, in drinking water or contaminated soil. Mercury can be found in some types of fish, and then arsenic can be found in rice and rice products at higher levels than other grains. So that's a big group of chemicals. There's another very large group of chemicals, thousands and thousands of what are called PFASs, which have been in the news more. Has anyone heard about PFASs before? Yeah.
Forever chemicals?
What's that? Forever chemicals, they call them, because why do they call them that, Kathleen?
They take a very long time to break down.
Right. So these are human-made, they're synthetic chemicals, and once they're made, they're going to be around for a really long time. So you might have heard of PFAS or PFOA, PFHSS maybe. These are chemicals that are found in stain or water-resistant fabrics like clothes and furniture and rugs. Sometimes they're already in them, sometimes people use sprays to make them extra resistant. They can be found in takeout containers to prevent like the grease from getting into the pizza box or the wrapper of your burger. And then these chemicals can also be found in some types of fish. And another group of chemicals are PAHs, polycyclic aromatic hydrocarbons. And Rebecca will be talking more about these later, but we actually measure the metabolites of these in our body, so when your body processes them. Pyrene is a metabolite, can turn into 1-hydroxypyrene in your body, and this you can be exposed to from car and truck exhaust and also from food. So, did I hear someone say about grilled food?
Yeah.
Yeah. Yes, when this hit the news, a lot of people are like, what? Like the crispy burnt part is like the most delicious part of like things, and that's the thing that has.
You ruined it for me.
Yeah, it's kind of. What's that?
Maybe a little less of
Right, yeah, just, in moderation, but yeah, that's kind of what we're here for. So I think, so there are, those are examples of chemicals that we measure, but there's like many, many more chemicals that can be biomonitored, and choosing which chemicals to measure is a really important part of designing a study. So, so now that you know what biomonitoring is, it's measuring chemicals in people. What is it good for? Like, what can it do or show? So, some things that biomonitoring can do, or it can show which chemicals are in a person's body and at what levels. Pretty straightforward. When we measure the same chemicals over and over in a group, like a community or a certain population, so at different time points, it can tell us who is more exposed to those chemicals, like are there certain groups or people who are higher than others. We can look at that, and then we can see how chemical exposures might be changing over time. So if like product formulations change, chemicals get removed from products because of changes in policy, we can see like, once that happened, do the levels change? Do they go down? And then it can help us identify ways to reduce people's exposures. So, so we can't find out a lot through biomonitoring, but there are some things that people might want or expect biomonitoring to do that it just can't. So just talking about some of the limitations of biomonitoring, it can't measure all the chemicals a person has been exposed to. So, we're exposed to thousands of chemicals every day through our whole lives, and there's just no way to, do tests and find all of those things. We just, we don't even know some of the chemicals that we're, being exposed to, so you need to know what you're looking for before you can find it. You have to know where to look, if it's in blood or urine or feces or something else. And you have to have a way to find it, so like a laboratory test. So we just aren't able to do that for every single chemical that's out there. And then biomonitoring can't tell us how much of a chemical is harmful or if your health will be impacted. So we find a chemical in your body, but that doesn't mean automatically that it's doing harm or that you will have harm in the future from that. And then biomonitoring also cannot identify the exact source of a person's chemical exposure. So it just tells us that the chemical is there, and we combine that with questionnaires that we always use in our studies, and other information like environmental monitoring that Rebecca's going to talk more about to try to figure out how people came into contact with the chemical that we found in their body. So next slide, please. So getting to our program, we are Biomonitoring California, and I think you can maybe guess from our name like what it is that we do, but we were established almost 20 years ago, which is wild.
Wow.
So, even Kathleen's surprised. It is, so it's a fairly, I mean, I always thought we're a new program, but yeah, that just goes to show how old I am now. So it was set up with these main goals, which are to monitor levels and establish trends of specific environmental chemicals in a representative statewide sample of Californians. So it's similar to what you all are trying to do in Vallejo, like get a picture of air pollution in Vallejo. We are trying to look at the whole state and see what's going on. What chemicals are people exposed to? Are there hotspots? Are there trends? Are things going up? Are things going down? Because that can help us assess the effectiveness of public health efforts and environmental policies to reduce chemical exposure. So we had some flammability laws about furniture catching on fire, and we had the highest levels of flame retardants of anyone in the whole world in California. And once we realized that, they changed the flammability requirements, and now we can see that those chemicals are going down, people. And then we also conduct community-focused studies as we can. And this was especially important in the early days before we had enough funding to do the surveillance, the first bullet. So we did smaller studies that were based on community groups that we thought might be more highly exposed, like firefighters, because of their job, and also groups that we are a more sensitive period of their life, like pregnant people. And another one of these early community studies we did was the ACE project, next slide please, which is a study of 4 metals and 32 of those PFASs into Asian American communities. So we did this in 2 phases with community partners. It was APA Family Support Services for ACE 1 in San Francisco in the East Bay. It was 100 Chinese American adults. And then phase 2 was in San Jose area with 100 Vietnamese Americans in partnership with Vivo. So, next slide please. And why did we do this particular project? So this grew out of work we did with messaging around safer fish consumption in San Francisco with APA. So, because Asians tend to catch and eat local fish and also just eat more fish than other race ethnicity groups. So they're getting more exposed to the chemicals that can be found in fish, like mercury. And APA had been doing this kind of messaging for many years, but they really wanted a way to make the issue more personal to their community members, because you eat a fish, you look at it, you taste it, you can't see the mercury, you can't taste the mercury, but if you get your mercury levels measured and you can see how much of it is in you, it might motivate you to make, safer fish choices. So we also knew Asians had higher levels of some metals like mercury and these PFASs based on some national studies and an earlier study we did in Central Valley. So based on that and interest from our community partner APA, we chose to study 4 metals and 32 PFASs. And we felt it was particularly important for California. We're a California program. We have a really large Asian population. So we could be exposed to the same chemicals because of our similar cultures, lifestyles, and diets, like fish. And then another point is that in other studies, Asian subgroups oftentimes were just lumped all together in one big Asian group. But we thought there could be differences in different Asian groups, so we wanted to divide them out and see what we found. So, so I think, we'll go back a few, please. No problem. So it's just a little.
I really did it, didn't I?
I think it's like the graphic of all the different steps of the study. So,
Yes or no?
oh,
Keep going.
Oh my gosh, how many did I hit?
yeah, you
I hit like a
it's
photo
full of
op
surprise at the end.
There we go.
So yeah, here we are. So there are many steps involved in setting up and conducting a biomonitoring study, but in communities like Chinese and Vietnamese Americans, it's just really important to have strong community partners. And we just couldn't have done this without them. Like, they're trusted members of these communities, and they can help us with outreach and engagement and building trust with the community and recruiting volunteers, because it's always volunteers, in the study. So that's the first step. And then for people who are interested, we meet privately with them. We explain exactly what's going to happen in the study, the risks and the benefits. They know exactly what they're signing up for. And if they're not interested, no problem. But if they are, they sign a written consent to participate. And this process is called informed consent. And then we collect blood and urine samples. And depending on what chemicals are being studied. But for ACE, we did blood and urine. And then we always administer an exposure questionnaire with questions that are related to the chemicals we're studying. And I'll talk more about the ACE questionnaire in a minute, but the samples get processed at the lab, and then when those are ready, we prepare packets, and we provide for people who are interested their own individual results, like exactly what we found in them, which is different to how this kind of study has been done in the past, but our program is really founded on the principle of right to know, because before scientists just thought this is very complicated, people will understand it, they'll get very alarmed, and we can just like present overall statistics, 85% of you have this chemical, but we wouldn't tell you exactly what you had in them. So we provide results for people who ask for simple don't want to know. They're like, no, I'll contribute to science, but like you can keep my information, but most people do want this information. So then after we return results to individuals, then we talk about them publicly. So we work with and do meetings in the community and other like dissemination of materials so that the larger community and advocates and scientists and lawmakers can learn what we learned. So next slide, please. For the exposure questionnaire, so I mentioned that they're always related to the chemicals that we're studying and include like the main ways that we think people are exposed to the chemicals that we're studying. So depending on what it is, we might ask about your job, you might ask about your home, like if you have carpeting in it, or and we usually ask a lot of questions about diet. If you remember, like what did you eat, how often do you eat these things? And for ACE, we just recognize that the exposure questionnaire we designed had to be really sensitive to like cultural practices and differences. So for Chinese and Vietnamese people who often eat rice and rice products, we ask lots of questions about what type of rice, where did it come from, how do you cook it, how often do you eat it, and then we also ask lots of questions about fish and seafood. So we wanted to be, make sure we were focusing, we included species that are commonly consumed in these communities. I know like sometimes there's fish that like other people might consider to be like bait, but like some communities like that's the fish they really want to eat, right? So we want to make sure that we're asking about the right fish. We want to make sure that we're referring them to in the right way. People might have different names for the same fish, so we want to make sure that we're communicating appropriately about what they're called. And then very importantly, we wanted to make sure that we didn't want to assume that people only ate the meat or the fillet of the fish, which a lot of studies had done. They just, do you eat this fish? You say yes or no, and that's it. But we know that Asian communities like to eat the whole fish. So we ask specifically about eating skin and eating eyes and organs because there can be higher levels of chemicals in those parts. And then we ask other questions about things that might be like in a typical diet, like seaweed, candy, spices, supplements, and traditional Chinese medicine, because those are potentially sources of the metals and the PFAS that we were studying. So we get all this information, we get everyone's samples, we get all these, these questionnaires filled out, and then what do we do with them? So the very first thing, as I mentioned, is that we inform and educate the study participants. So before they get their whole packets, if anyone has levels, what we consider to be elevated levels of metals, we have what we call levels of concern. And if you're above this level for arsenic, cadmium, lead, or mercury, we do special follow-up as soon as we get these results to let people know. And then there's a voluntary questionnaire which has more questions about like less common sources of these chemicals. So we look at the original questionnaire, and then we've got other more detailed surveys that ask about maybe more unusual things that somebody might be exposed to, kind of help them identify where they got exposed and also to avoid more exposures in the future. And then we have, so everyone gets all their results, and they don't just get like a piece of paper with numbers on it. We also show like the study results, like the summaries numbers so you can see if like you're above the middle level or below it, or if you're, you know, towards the high end. We compare with other study participants, and also there's a national study, so you can see how you compare to the general US population. And then we always give chemical fact sheets. For every chemical or group of chemicals that we return to people, we tell them where, you know, the main sources where they come from, what the possible health concerns are, and then ways you can reduce your exposures. So that's the first step. And then we next share the information with the community organizations. So they help us to organize meetings in the community so we can let more people know about the findings. We talk about overall findings, never reveal anyone's individual results. And we rely on our partners also to help us develop and disseminate the findings and other materials that we may have identified a need for. And so one thing that we have developed with really strong support for these groups is arsenic and rice products fact sheets. So this is a finding from a long time ago. It was in the news, I think 2012 or around that time. That there was a lot of sort of chatter about the fact that like rice had so much more arsenic in it than other grains, and so it made a big splash in the news, and then it kind of like died down. And I think some people thought, well, everybody knows that by now, and other people, you know, just it wasn't on anyone's radar anymore so much. But it had been out there, and then it seemed to kind of go away. Someone like me, it's a lot of rice. I still thought about it, but I was like, this is really a problem. And you know, we found that a lot of people in the study like had not heard that. They were like, wait, what? Like rice is not good. We eat rice all the time. Like what's the issue? So we identified this need for like a plain language, graphically, you know, nice looking fact sheet that was developed with like the help of these community partners. They organized focus groups so we could test out language and like how do you tell someone, you know, deliver this message, which is potentially really controversial and upsetting, and you know, what images to use. And we've done this process in Chinese, Vietnamese, Spanish, and English, and we've developed these fact sheets now that will be handed out to all of our participants, and a whole big campaign with our community partners to get it out to the general public. And then we're going to have a social media campaign that we're hoping that our partners can also help us like promote our posts or boost the likes or whatever the language is, but you know, get things out there in ways that like people consume information now. So next slide. And then another thing that we on an ongoing basis that we do with our results is that we explore those questionnaires and look at the data to see if we can make links between like diet and behaviors, like all the things we asked about, and like levels of chemicals. And one important finding from ACE was that people are getting exposed not just to mercury from seafood, but also PFASs, and especially fish that are caught locally, and if you eat the fish parts. So we've worked with our community groups, also made presentations to state and national groups who work on contaminants in fish, so this can help advise like the fish advisories. Like I know like Caribou, like if you go down by the water, you see those signs, and those don't talk about PFASs yet because we just don't have enough information. They're based on mercury and other things, but we're hoping this will get incorporated into that kind of messaging and those advisories. We're going to have like a scientific article that's published in a few months. Along with that, as a plain language fact sheet to make those findings like more accessible. We're translating that into Chinese and Vietnamese and getting that out, and we'll have a social media campaign for that as well. So you can see that doing a project like ACE in a community can really have wide impacts. Starting with participants, it can be very beneficial for them to learn about exposures and use those materials we give them to make changes to their diet and lifestyle, particularly if they've got, have been eating a lot of fish with high mercury, they can switch to low mercury fish, or to pay, more attention and make safer choices during pregnancy. Community organizations can advocate, they can, take our information and do educational campaigns, or, advocate for more signs, or like signs that cover PFASs, for example, just, they know what their needs are, and they can, if they know, how their communities are being exposed, they can advocate for them. And local, state, and even national health and environmental groups and researchers can plan studies based on what we've done, or interventions based on our study findings. And then last but not least, we ourselves can just learn lessons from the studies that we do. We can improve our questionnaires, we can, inform studies in the future, based on on what we've learned every time we do the study. And I think that's it. And that is my email. I'm gonna hand out my card as well, but we're gonna save all the questions to the very end. I'm just gonna hand it over, and you can please feel free to email me or call or hand out my information if you have any questions that we don't get to at the very end. But I'm gonna pass it to Rebecca, who's gonna talk about community biomonitoring studies in 617.
My name is Rebecca Veloso, and I am a part of the California Environmental Protection Agency under the Office of Environmental Health Hazard Assessment, also known as OEHA. And I am also part of Biomonitoring California, which is made up of 3 different agencies, including OEHA and CDPH. Okay, so I'll be discussing the activities that our side of the program does to complement the Community Air Protection Program. So Biomonitoring California supports CAP by working closely with different community and academic partners to develop, design, and conduct biomonitoring studies, often in communities that are overburdened with air pollution. And so the activities that we engage in include adding on a biomonitoring component to an already ongoing study. We also partner with communities to help identify different sources of air pollutants and chemicals that they are concerned about. We also help design studies that address community concerns and explore laboratory collaborations. Next slide.
Different setup.
There. So today I will be briefly going over 4 of our recent studies. Some are completed, some are ongoing. So the first one would be the East Bay Diesel Exposure Project. Next slide. This project is also known as the EPDEP project, and it took place in the East Bay in 2018 to early 2019 with the goal of learning more about diesel exposures in families with children that live near roadways and highways. So we looked at this by addressing exposures in households, as well as looking between communities and over time, and with the hope of generating data that will help us evaluate the effectiveness of current diesel regulations in California. So I also wanted to point out that we work closely with the community partner West Oakland Environmental Indicators Project to help carry out the community engagement portion. And Zwen also had a really big role in this project, and she helped lead this project. So thank you so much. So
Visited a lot of families and homes.
Yeah. Great. So next slide. So as a general overview, the study population consisted of 40 parent and child pairs that lived in the areas that are highlighted there. We collected environmental and biological samples along with questionnaire and activity data in order to analyze their exposures. So in air and dust, we actually measured 1-nitropyrene, which is thought to be an indicator of exposure to diesel exhaust. And in urine, we measured metabolites of 1-nitropyrene and 1-hydroxypyrene, which are metabolites of a chemical known as VOCs. So did you discuss VOCs as well?
I didn't talk about no, but I can talk about the pHs.
Okay, yeah. So VOCs is another component of air pollutant that can contribute due to diesel exhaust. So we're just looking into that as well. And so we also looked into pHs, and we'll be looking at the preliminary results that came out from EPDEP. So this was published in 2003, and this paper included a description of the project as well as demographics of our participants and results of 1-nitropyrene metabolite that was in the air. We'd like to highlight a few points. So the first point is that at least 1-nitropyrene metabolite was present in about 97% of the urine samples. This generally happened, it was generally higher in fall and winter months compared to spring and summer months. Lastly, air and dust in 1-nitropyrene levels were higher in homes that included a high cal and virus screen diesel score. So I don't know how many are familiar with cal and virus screen, but that is a tool that our office creates and updates in order to help inform communities and other researchers about the air pollutants and other contaminants that are affecting different communities. So it's a really, really neat tool. So we use that to help address this. Next slide. Recently we did additional analysis of EPDEP data. So we found that 1-nitropyrene and dust air were associated with nearby traffic and roadways. And the metabolites of 1-nitropyrene that were in urine samples were positively associated with the length of the roadways. Additionally, we looked into VOC metabolites, and they were associated with different demographics, traffic density, length of major roadways, as well as things that are found in the home, such as gas appliances and candle use. Okay. So the next study I will discuss is the Stockton Air Pollution Exposure Project, also known as SAPAP, which took place in December 2021, with the goal of looking into air pollutants that are affecting school children in Stockton. We also had an intervention to evaluate the effectiveness of air filtration in classrooms. And we work closely with a community partner, Little Manila Rising, that is headquartered in Stockton. Okay. So as an overview, we enrolled students from All Saints Academy of Stockton. The principal was very highly involved in developing community emission reduction in Stockton. So thankfully our community partner was able to get in contact with her, and she let us conduct this study in their school. And we looked into the air pollutant levels inside and outside of the school with air monitors. We also installed portable air cleaners inside the classrooms of students that were participating in the study and had their parents complete questionnaires. We collected children's urine before and after school. This only took place two days throughout 2 weeks. So we were able to look at before and after the information. And then measure chemicals as well that indicate exposure to air pollution, like some of the metabolites that we have discussed already. The goal was actually to enroll 50 students, but due to the COVID pandemic, and it was a lot more difficult to recruit enough participants. So in actuality, we recruited about 18 students. So it's not a huge sample size. So some of the data analysis that we've done, we were careful to interpret for the wide community, but we think it's still valuable. Next slide. So what were the results? Based on the portable air cleaners, it showed that the classroom air pollutants were reduced by about 25 to 50%, and this is over encompassing several different types of air pollutants. We also looked into the urine measurements. However, we didn't see that there were significant changes in urine levels of the different air pollutants specific to PAHs or VOCs. But that's okay, that's not too surprising. The levels of urine represent exposure from all sources, so not just in the classroom. And the dates that we collected, urine was actually right after the weekend, so it's possible there were other exposures that the children had over the weekend.
So the urine would have to be metabolized.
Correct.
So it's,
Correct. We also look into the, the time points at which the air pollutants can be metabolized through the body. So it varies depending on which pollutant that is. All right. But overall, we feel that the results tell us that purifiers in schools can help lower exposures to some of these chemicals that would help children not be as exposed in school. We also compared the urine results to a national survey called NPAINS, and we found that most of the chemicals were about the same or lower in the SAPEP participants, which is good news. However, we also did find that some participants had higher levels of a certain metabolite called 2-naphthol, but we're still investigating to see if that is something due to the region, or if this is something that's increasing throughout the rest of the country. So some of the data that's collected by the National Survey is a few years old. Next slide, please. Okay, so the next study is called the Biosphere Study, biomonitoring component of the San Joaquin Valley Pollution and Environmental Health Research Study. So this is also conducted in Stockton and Fresno counties as well, with the help of our community partners, again, Little Manila Rising and CCAC Central California Asthma Collaborative. So the goal of this study was to assess air pollutants among parent and child pairs living in those areas, and with the goal of looking into the air pollution in those regions and providing some data to help interpret the results of our previous studies, including SAPEP. Next slide. So as an overview, we have about 64 parent and child pairs. So we also sampled for several metabolites, and we also measured in SAPEP and added on nicotine, and looking to see if we're still analyzing this data to see what the associations are. So we looked into between individuals, within individuals over time, and across the two communities. So this is still one of our ongoing studies that we are working on. And then our most recent study is the Farmworker Women and Respiratory Exposure to Smoke from Swamppool Air, also known as the Fresca Mujeres Project, that occurred in 2023. And this was located in the Central Valley. So it investigated air pollutant exposures among 50 female agricultural workers from Kern, Fresno, and King counties. And there was also an intervention portion to evaluate the effectiveness of air filters on their swamp coolers, which is this kind of air conditioning unit that's adhered to the side of their walls of their home. We incorporated additional filters attached to that and measured the indoor air to see if there was a difference before and after certain time points, with the goal of understanding more if it would help clear their air during a wildfire event. Unfortunately, there wasn't a wildfire. I mean, it's fortunate for them, right? But for our study, it is unfortunate because we couldn't do this analysis of whether or not it worked during a wildfire event. But those areas in general are also highly polluted, so in the end, it still gives us some valuable data. Great. So to go a little more into our biomonitoring, we collected urine samples before. We thought there would be a wildfire event, so in the springtime, and then we also measured in the summer/fall during wildfire season, and we analyzed. we collected one sample at each time point for oxidative stress and inflammatory biomarkers, and then we also took one morning sample in the spring and then 2 samples in one day during the summer and fall, and we looked into other metabolites such as pHs, VOCs, and we added on metals because wildfire smoke is known to have some metals in it. So we wanted to see what their exposures were. Alright, so this study is also ongoing, but we have panel meetings, our scientific guidance panel meetings where we discuss some results, preliminary results from the studies, and we also hold community meetings. So we are going to present soon, and we can share that information once we do that. So I also want to share, we have some chemical fact sheets on our website. This is one of our newest fact sheets on volatile organic compounds, and I printed it out, and they're still at the front table, but you're welcome to take as many as you want home. So we have about 38 of these chemical fact sheets on our website, including different chemicals and chemical groups such as air pollutants, flame retardants, heavy metals, pesticides, plasticizers, and many others. So you feel free to scan the QR code if you want to find out more. And then, next slide, please. We also have new and exciting informational fact sheets that we just worked so hard on this past year, which is what I believe has passed around the room. So there's 3 different fact sheets. One for introduction to biomonitoring, which goes over what we talked about, and how biomonitoring studies work, and then also some more information on supporting also. So what's next? Like I said, we are still working on some of these studies. So we're in the process of publishing the study results for SAPAD. And we are returning results to participants for our Biosphere and Fresca Mujeres studies, and in the process as well as of results of analysis. So, like I mentioned earlier, we'll be presenting that to our scientific guidance panel, and we'll also post the results on our website. Next slide. Alright, so if you have any other questions, please feel free to email us. So I put her email up there, and then this is our general inbox, which I have access to. So thank you. Have any questions for us?
Do we have time for questions?
I know, is there time? Thank
I'll hand out more cards.
Question? Okay. One of the saints are friends from California Department of Public Health to come.
Sorry, I had a question.
Oh, good, yay!
The first presentation in terms of PFAS, what can biomonitoring tell us about the method of exposure? So for example, PFAS, we can get that from our clothes versus actually eating fish. Is there any insight biomonitoring can give us?
Yeah, ooh, Kathleen, I might call it Kathleen, she's our PFAS expert.
Well, inherently, usually just measuring it in your blood isn't going to tell you exactly which place it came from. Your body mixes it all together once it's in your body. But as Wen showed, there's sort of different kinds of PFAS, so you can like look at the ratios between them, and that might give you a bit of a clue. Like this comes more from drinking water, or maybe this comes more from dust, or maybe it comes more from fish. But generally, policy-wise, our efforts are just to try to get levels down in all the sources, right? So, yeah.
And then just a follow-up to that, for just consuming the fish, when you had questionnaires with participants, was there anything that highlighted patterns of when you asked us to eat the eye versus?
It was by specific parts. I think it was just all the like any part, right? Would have more. You would have higher levels of PFAS.
Well,
Yeah,
it is
that's
actually
it.
divided out into
Yeah.
the different organs or the different parts.
Right, but like you could see like you're much higher in a certain one if you ate only the eyes or something. I don't think we had enough numbers to like
Yeah,
say
didn't have
that.
enough numbers for that.
Yeah. But I mean, it's an excellent question, like, this is something I was worried about, because coming from Vietnamese culture, like, if you don't have good eyesight, like me, like, they say eat the eyeballs of the fish, it like makes your eyeballs stronger, and so I was thinking like, hey, yeah, it's like our eyeballs worse than the rest of the fish, and then I started Googling it, and this is like while we were doing the ACE study, and it was like, eyeballs are higher in mercury, like, so much so it affects the fish's eyesight, like it can interfere with like, it, you know, it like makes them blind, or, you know, like really affects the functioning of their eyes, and then if you imagine if, like, I'm the one with bad eyes in my family, and every time we fish, they're like, well, you take the eyes, because, you know, you need it for your eyes, and then, oh my gosh, like, I'm the one, you know, getting them, so I still enjoy eyeballs, I don't eat them as much, you know, just to read, you know, I like them, but like, you know, not so much that I want to expose myself to, like,
You fight over the eyes.
you do? Right. So just knowing that sort of thing. I mean, I have been in meetings not that long ago where it wasn't like a well-represented, I think, like attendance in terms of like diversity, and somebody did say, nobody eats other parts of the fish than just the meat, do they? And I was like, what? Like, what are you talking about? Like, so many different cultures like do eat the other parts, and so it's just really important when you're doing a study like this to ask. If you just say, do you eat fish? Yes. What is that really telling us? So, you know, we are not perfect that we, you know, when we presented some of these these findings, people were like, oh, and so did you find out where people caught these fish? And then we're like, oh, no, we didn't ask. Like, so like next time, like if we're doing a study with locally caught fish, we will find out where people are going. So this is how we like build on what we're doing.
Can I further address your question though? In our government setting, where Department of Public Health works with Cal EPA agencies, which OVHA falls under, the environmental context definitely does come into play, where we know chemicals exist in air, water, and soil. So to the air program, community air production program, air districts are supposed to add context with emissions inventories. But like, okay, that's not yet come. Once that does, if it does, with like certain emission sources like a refinery or near an ag field or near whatever, that would help narrow down the field of what are we exposed to. So we know, for example, diesel is represented by back carbon measurements, and then so we know diesel also affects health outcomes in certain ways, and that's the way that scientists like myself like will help figure out. This came from that. That also coupled with biomonitoring to know in our blood and urine and whatever we are exposed, and it's likely from diesel from trucks. Then that's how we piece together that information.
Right. So biomonitoring is just one piece of that puzzle.
And OVHA has a fish group that focuses on the notices that Zoe
Yeah.
is talking about which fish, what time is each fish safe to eat. And they also have recommendations on cooking fish, so the parts are safe.
And we have a different team for CalEnviroScreen, which are indicators of not just like environmental pollution, but also socioeconomic, like race, ethnicity, like those
Right.
those are different
Linguistic
categories of 21
isolation,
indicators.
like, yeah, if it's a community that doesn't like speak English as a first language, and there's different, you know, terms and like ways to address issues in those communities. You have questions?
Question, yes. Now after we talk about fish, I'm talking about rice, because as you
I
mentioned,
know.
like Asian people eat a lot of rice.
Yes.
So our cynics are, when you go to a supermarket, you see rice from United States, from Thailand, from Vietnam, and so did you have any idea where?
Which country?
This
Yeah.
is an excellent question, and I'm sorry to say we don't really know yet. So if you Google this, and I hope that you do, like when this came out, like in 2012, there were some recommendations saying like, oh, you know, rice grown in certain areas, like California is low. It was based on a very small sampling of rice, like and not a lot over time, and so what was true then may not be true now. There are some other like limited testing that's going on, but there's really people kind of accepted, I think, that California rice was low, and so they didn't like continue doing testing. But like things can change. Like arsenic is not something that's added to rice. Rice is very good at taking up arsenic from the soil and the water that it's grown in. So when there are places in the U.S. like that used to grow cotton and they use arsenic as part of the growing process, and then you grow rice there later, there's already a lot of arsenic, and that's going to be higher. So we do just say like avoid rice that's from areas that grow cotton. But like, how do you know? You see U.S. rice. Is it Louisiana? Is it Texas? Is it California? I feel like California rice has good branding, if it's from California, you know it's from California. But you know, it just what's that? Cal Rose, right? There's lots of different brands. So like there are parts of the world where there's a lot of arsenic, where you wouldn't like Bangladesh. It's just a problem. People can't drink their water out of wells, and so like I would say in general, I don't eat rice from Bangladesh, but I don't even think we find rice from Bangladesh in this country. But otherwise, like to reduce your, but it's very hard. You don't have results for each bag of rice. Some brands test the rice and post their arsenic results online, but like, is it every field? Is it every bag? Is it what, which, if they grow in different areas, is it every area? So you have to sort of like be cautious about like, just accepting like, oh, this is low because they're showing me one number. But one way you can reduce your exposures, which is something that I have done, is like I love to buy a 50-pound bag of rice. I get the new crop, and then you have it, the fresh cut, and you eat from that bag. If that rice is high in arsenic, which I have no idea, I'm getting high arsenic every day. If I buy a 5-pound bag of that rice and eat that, and then I switch to a different brand, maybe 2 pounds, or I go somewhere else and I buy 1 pound, it's fancy rice, it's expensive, I want to buy 1 pound, but then if you mix up like the brand of rice, where it comes from, like the volumes that you're buying, this is one way to just get variety. So you're not getting, you're like, kind of like spreading your senses. What's that?
Get the tortillas.
Yeah, right. Well, it's this issue too. Like for people who are gluten-free, like they tend to eat a lot more rice just because rice flour is substituted for the other grain flour. So it's just there's all kinds of different groups that,
Parboiling technique, right?
And then the other technique, the other way to do it, which I'm trying, but it does take more water and time. So you can take your rice and boil it in a lot of water, like pasta. So like, a lot of extra water. Like 4 cups of water, regular rice. You boil it for 5 minutes. You pour that water off. That's the arsenic water. It's reducing, like it's getting rid of some arsenic. You put more water in, usually less than you would do, and then you cook it until it's done. So the remaining rice, I think it's like 40 to 70% reduction of arsenic. So, and rinsing it does not remove arsenic. So I rinse the rice 5-6 times so the water is clear. But you can soak your rice overnight, throw that water away, rinse your rice, put new water, and that'll reduce it some, but not as much as cooking it for 5 minutes or boiling it, throwing away the water, new water.
Okay, that's what I was wondering.
Yeah, yeah. There's another goofy thing that some scientists did where you cook it in like a coffee maker.
Yeah.
So you put the rice in and water goes through like when you make coffee, and then the water is taking the arsenic away with it. But I don't think I've never tried it, but if you try it, you're successful. Let me know. And also, spoiler alert: brown rice is higher than white rice because it's in the out. I know. I'm so sorry. You're like my mom. She's like grilled spoon and brown rice. Like what can I eat? Yeah, so brown rice it's a complicated message because people, have health concerns like diabetes and they're told to eat whole grains and they eat brown rice and then brown rice has more arsenic and so So we did really work hard on this fact sheet, which I hope will be coming out soon, and you can give us feedback if
Choose your
what you
poison.
think we did. What's that choose your poison, right?
Kill you right away. One thing which I think since we have the people here, I didn't hear is a research for the refinery community. So maybe the next one.
Yeah, I think you're going to be maybe designing a study eventually, right?
And also, I think our group has a special advantage because we work with UC Davis and Dr. Strada, which they do PM speciation. So basically, I think a lot of things, for example, for the biomonitoring part, we just test things from already coming into the body. And as mentioned earlier, like there's so many, which one we're testing, but if we can combine, for example, testing soil and testing the air, through the speciation, we can kind of say, okay, we have a high this thing or that thing, and then we can probably focus on the biomonitoring part to look at that specific element.
Right,
So-
and things that are coming from the refinery, and then maybe there's not a lot of that same thing coming from other sources. Also, where would you look for that chemical? Do you look in urine? Do you look in blood? Or like some chemicals it's best measured like in your feces. So like usually the time, like we've never done a study where we collected that from people, I think for obvious reasons. And so if that's the best way to find it, because it's processing through your liver, then maybe like there's just, you know, not a way for you to collect and analyze that. So, and you know, we've done to the point about like knowing that it's, you know, being sure that the refinery is a source of something. And we've gone into studies like with the firefighters where we're like, ooh, we're gonna measure PAHs in firefighters because it's smoke, it's burning things, and we're gonna like see higher levels in firefighters like while they're on the job versus not on the job. So we did ask when did you last work, all these things, and then we saw people with like high levels of PAHs, and we're like, this must be the people who were fighting the fires. And so we like looked at the questionnaire data and we're like, no, that's not what it was. And we're like, why are these people? And they're like, oh, they're all in the same firehouse. We're like, okay, like are they in a polluted neighborhood? Like what's going on? And we just like we really looked hard at the data, like the questionnaire, like what do these people have in common? And so do you know? Can you take a guess at like what might have happened with that group of firefighters at that firehouse that caused them to have higher levels of PAHs? You might have a good guess.
They barbecued all the time.
Exactly! They grilled chicken, did it because they live in the firehouse, right, for 3 days or whatever. They grilled chicken the night before. So not just grilling it, but eating the chicken, and so like they all had higher levels of PAHs. Not from their job, but because of their dinner.
Also, possibility is if they do like special like firefighting agent, if they're fighting
Yes.
like a refinery fire,
Yes.
they use
PFASs
Yes.
are in those, yes. And so you do get hot spots of PFASs, like in airports and places where they do firefighting training. You know, they spray that foam around. There have been areas that have just been really contaminated. So the soil, fish that you catch around there, there's just higher levels of PFASs from that kind of activities. Yes.
Just for the group to know,
Uh-huh.
our organization is currently measuring the air in Benicia, about half a mile or less
Right.
from the Valero refinery. And it's from UC Davis. It's not Dr. Spada's group. Is the other one that is testing toxic, 16 different metals. So it's a machine that pumps the air in, goes inside the chamber, there's a little spark plug, burns the air, measures the chemical, and reports back to Davis. And it's been in my daughter's house for 3 weeks today.
Oh,
3
wow.
weeks already. So we're about ready to pack up and wait for that.
And I'm curious, so you chose half a mile because you know that like that's how far metals generally like travel from a refinery, or do you know why like half a mile was chosen? I'm curious.
That's where my daughter's house is.
Oh, okay.
And you know,
I thought you had to
Yeah,
do
the alley,
Yeah.
next to
and Benicia is also downwind from the the
Right.
most dangerous refinery in California.
Right, so it's not
Martinez.
in your community, but it's, yeah,
Yes.
right. No, I know, and I know like Chevron Refinery, just the way the winds go, like they have an event, a lot of times that smoke can just be sucked into the Central Valley and ends up in like Bakersfield and Fresno, like instead of like the immediate community, so you do have to like understand about how the things
And we've
travel.
also had a machine that some kid in Davis invented. It's
Oh,
only
yeah,
a wind,
I saw it, yeah.
wind sensor.
Yeah, I
So
saw
you
that
could
then.
you could correlate that with the
Yes.
direction. So you could say, okay, this high, reading is high. Where was the wind at the exact same moment coming
Yes.
from? And that machine will
Yes.
tell you. Well, the data is already being stored
Right.
itself in the cloud.
Right.
It's one of our projects for a group to.
That you collect it and store it, yeah, right. Because I know some refineries have like real time, you can look what's happening right now, but you can't look what's happening 2 hours ago or, you know, yesterday, right?
So I have a question, is anyone monitoring microplastics?
You know, that's an excellent question. People have a lot of interest in microplastics.
They never biodegrade in our
I know.
bodies.
So the issue with microplastics is that they're made up of a lot of different chemicals,
Right.
right? Plastics are made up of so many different things, and a lot of times the particles like are not. They're just. It's like not reacting with your body on a chemical level. Some they can get so small that they do actually react in that way, but like how microplastics, like if we can biomonitor for you've been in some meetings, right? And about microplastics with Larissa, just talking about
Yeah, the
application.
methods we're still developing.
Yeah.
Yeah.
I
There's a
think-
lot
I
of
think concern-
definitional
Yeah.
things, like what size are we talking about?
I think we've been aware of arsenic and lead for maybe a long time, generations.
Roman
Whereas
Empire.
microplastics is kind of a
Yes.
newly showing up
Yes.
thing.
Right.
Right.
Phenomenal,
Like
where
fibers.
birds are
Mhm.
dissected and they're full
Right.
of plastic.
Right, we've got plastics in our
Yeah.
brains and, yeah. Yeah, I think we all have like a teaspoon of plastics in there.
Yes.
Yeah, explains my memory, huh?
Yeah, so I was wondering,
samples from not all of us, like samples and data sets?
Oh, yeah, I mean, they're a biomonitoring effort. I mean, have you looked at like what they like are measuring lately?
Yeah, I think most of the samples that are from California, well, no, this is a little historic. It was down in Southern California that they're really contributing samples to, but it's a nationwide effort. It's a big health study generally,
Yeah.
so like the environmental biomonitoring part of it is just a small
Tiny.
component. But
I
yeah, we
think,
continue, like we try to keep in contact with all these different organizations to learn.
I heard at UCSF that like a lot of the patients are enrolled in that here
Oh.
in the Bay Area. Yeah, I get they also have the informed consenting, which I signed up for.
Oh, all right, yeah.
Yeah, I was just curious. Yeah, that's it.
So who do you guys compare it with to say this is good, this is bad?
Who do we compare? Okay, well, that's an excellent question. So yeah, a lot of these things we do not know
You
necessarily.
just kind of,
Necessarily like what what level is going to like have an effect on you, but it's similar to like like blood pressure, like what's normal blood pressure. The only reason why we know is that we measure like many people, like, and then we just see like this is the range, and it's like people should be in here, and if you're like at the other end, it's like it's not normal. So for the same thing for biomonitoring, we just need a lot more data in order to see like what the range is and just how it's distributed, and what like if we can put together health data, we can say, oh, like with asbestos, like this is a very unusual case, but like there's this very specific cancer that's related to asbestos. But if we can do larger studies, like there have been things, like studies showing people who live closer to freeways have more heart attacks than, strokes. So we can, if they get biomonitored, you can see, well, is there a certain level that you're more likely to have a stroke or a heart attack? But it's just one piece of that puzzle. But the first thing you need to do, just like what you're doing with air monitoring, is just get like the whole picture, and then you can sort of identify like problem areas or, groups that like have more exposures, and then if you can like find out their health data, then you can see if you can make links between exposures to certain chemicals, just having them or not, or just having certain levels or not. And but you can't ever say, I mean, it's I hate using the example of like smoking, like we know it causes lots of like health problems in general, but then someone goes, oh, my grandma was 100 years old and she smoked every day and she never got cancer. What's that?
They used to be different cigarettes, less
Oh.
chemical.
Yeah, I mean,
So technically it makes
And I
sense.
think also the toxicity becomes generational. So if your great-grandmother was a smoker, the chances are that for all those generations coming up to you, they all smoked, you're going to be a more concentrated specimen.
we did, I think we talked last time about like you can see generational effects of things, and it's true, there's like a 3-generation study where they study pregnant women, and the ones who were pregnant with girls, they studied those girls when they were born, and then they studied the children of the girls
That's
who were
right.
inside the original, and they can say, oh, people who are exposed to certain level of chemicals that are more likely to have certain kinds of cancers. This means it was an egg inside of a baby
Right.
inside of a woman in like 3 generations.
So they did that with
But
dioxin.
You're spiraling a little bit.
I know.
You're spiraling a lot. The
Yeah.
question earlier about like how do we know quote unquote safe levels?
Yes.
There's animal toxicology studies, epidemiology studies, different kinds of even in silico studies where toxicologists like myself, we do one chemical at a time. Unfortunately, that is the traditional risk assessment paradigm. It's like 10 years ago plus when I was in the Prop 65 program, which biomonitoring also kind of integrates with. We look at toxicity data, epidemiology data, a whole bunch of different data sets. And so one at a time, be like, okay, for example, BPA, bisphenol A. This is the data set on it causing reproductive toxicity. And so we could develop what was known as a maximum allowable dose level for that chemical before we would say reproductive harm started happening. So we have roughly 900 chemicals in the Prop 65 program that are listed, probably a little bit more by now. But all of that is to say, we take data sets even from federal scientists like US EPA, NIEHS, these other bodies, and then we contribute to that as well. As science goes many different ways, we look at literature, we look at future studies and these things. So with air pollution, also, it's not a maximum allowable dose level, it's a reference exposure level. As
monitored concentrations are taken, just ambient monitoring. We don't live directly next to the pollution source, hopefully, but I know it happens, that different populations in the community have different risks. Those closer that are there all the time, likely more at risk. Those that are downwind, farther away, generally better off because they're not so close. And so that's what makes public health so challenging, is we have individual exposures with different contexts, we have community exposures, like who as a community is more likely to be at risk than like downwind. Like Oakland Hills, better off than like West Oakland, for example. And so that's where this complicated messaging for us public health and environmental health sciences are like, well, we don't know, because what do you eat? What do you do? Where do you go?
Right, and if you do under one each chemical, okay, but then like you're not just exposed to one chemical in your whole life, and it depends on like when you were exposed to, like were you growing and developing at that time, you know, what other risk factors, like genetically, like all these other things. It's a very complex, so we can never just like draw a straight line and say, okay, you were exposed, and you know, you can, yeah, the straight line between this exposure happened at this time and this is why you got this you know, disease or this condition, which is.
Well, I think that they did studies with dioxin where they were able to prove, I don't know, when I first heard about this, they had done like 5 generations and they had no reduction of potency. So, you know, this chemical that was exposed all over the world is, so is that being studied with, within your biomonitoring?
Dioxin specifically, it's not something that we've done studies on, but we work with people who work, who have expertise in that area. And it's, you know, similar method, interventional shares and things like that.
But these are why some environmental toxicants are so hard. Like lead, we've known about for many
For
years.
generations.
The diethylstilbestrol, the chemical I think you're alluding to with the multiple generations of women and daughters, that was actually used early on as a drug to prevent miscarriages.
That's right.
But then it was like, oh, these are causing more problems to daughters of daughters who
That's
use
right.
this. So like it takes science time to figure this out, and that's part of this challenge of evolving environment of like we have so much. Which way do we do?
Yeah, there's so much.
Yeah, so much we know, and then there's like new
Variables and
chemicals coming out all the
products.
time, so you have you like, stay on top of that.
Well, you guys are gonna have work forever.
I had this moment a while back where like you look at like Victorian times and they have the deadly green wallpaper and the lead paint and stuff, and you think to yourself, oh, thank goodness we got smart, we don't do that anymore.
Oh, yeah, right.
And then it hit me one day, wait, it's only gotten worse. It's like, oh no.
A lot of things have come.
Occupational protections, right? Like,
Bring up drinking water.
you don't lick your breath and put the mercury on the, you know, face, or you know, the hats and
Or the dental fillings before they emerge.
Oh, yeah, I know. My time,
Yeah, isn't that amazing? They used lead amalgam in our mouths for fillings.
Wait, mercury and all.
Mercury. Oh, yes, I'm sorry, you're right, mercury. Well, and that is one of the controversial things about infant vaccines, is they used to be preserved with mercury.
Yeah, they got that.
And they got it out of there.
Right, but then it's hard for people to.
Yeah, but it's hard.
But when I was a kid, fun part is when somebody breaks a thermometer.
Oh my gosh, I
Oh,
know.
yeah.
Oh,
I
yeah,
know.
nothing was
Yeah,
cooler
so
than
much
mercury.
Yeah, right, it still happens, you know, and then we get kids who have like really high blood pressure, and we're like, what's going on? And then they're like, there's no mercury in the house, you know? Yeah.
So much fun with them.
Oh. No more.
I think most of them don't have mercury anymore. Right?
There's some, candy thermometers, I think people cook with them, like, you know, they're still around, but yeah, less. Great.
Great, this is a wonderful discussion.
Thank you.
Just use big staple rubber.
Oh, yeah, right. My grandma.
Big staple rubber.
And also I want to mention, like, Rebecca driving from Sacramento is like an hour. more than an hour. And think about it, today is Saturday, which is
Oh my
not
gosh, thank
there.
you, Professor Desai.
Yeah,
Dr.
that's
Collins.
Really wonderful. People coming here to do the business. We have 2 more things. Okay. One is, we are going to, we talked with the group from People's Garden, and on their project, they have some wonderful ideas. So we want to give them a few minutes to tell us more about what they are going to do, and also, for example, some of the challenge we faced in the past and how they overcome that. It's an international solution.
Okay.
You want to come up here? Or with your slide on fabric.
Auntie Eva just left us right before we were gonna present flags. So the reason why we chose fabric is multiple reasons. One is because we plan to do these presentations over at the garden or at outside, and technology outdoors is not the greatest sometimes. So we were able to get these made actually in the Philippines because it's cheaper. So actually we're not done with it. We're gonna put it on a board and we'll be able to be able to make it better. So our project has to do with a lot with indoor plants and how we can best educate our community, educate others on how we can make a difference in the places that we live in our homes. And so we can't always prevent things that are happening around us because everything's happening around us, but we can definitely make a difference in our homes. I see if you can come up here and help me. We plan on speaking to a lot of different groups. We have we run an after-school program on the island, so we plan on also speaking to students in how we can help them and their families bring these certain type of plants into their homes, which will help in the reduction of pollution and things like that. And we will also be, because of our relationship with the garden, we will also be making these plants and be able to distribute these plants and and teach others how they could plant these plants also to bring them in their households. What do you have?
So another, that's in the home, but we also partner with agencies such as the Healthy Vallejo. And Healthy Vallejo is a nonprofit organization that cleans the encampments. And so we've started dialoguing with them. So what we're gonna do is when they clean up, we will plant plants rather than just leaving it empty again.
Nice.
So Vilma with the Vallejo People's Garden, and we have the master gardeners, we will be teaching them how to plant. So that way, they will also learn the importance, and we will educate them. So we will educate them about the importance of plants and planting the trees that are good for, yes.
What's another question? So, your encampment is gone, and you're gonna be planting things. Who are they that are gonna plant?
The Vallejo, Healthy Vallejo is a nonprofit organization.
Oh, the people? Oh,
Yes.
Oh, okay.
They are,
So what they do, they employ young people. They
Yes.
employ youth between the ages of like 15 to 24 to clean up the streets of Vallejo. And then afterwards, the plan is where we can also kind of bring in plants in the places that
And then-
they.
And then watering them.
right, yeah, that's
Yes.
part
So
of
it's
the
gonna be,
responsibility.
Okay.
Yeah, so we applied grants together with them so that we will be able to continue doing this and also using, the resources wisely so that we can, not only that, but we will make sure that it's Vallejo, like I said, making Vallejo healthy. So that's the goal, and we are partnering with them and we're moving forward, and hopefully we will be starting to do that by May.
Wow.
Tell us about the story. Why do we go with the fabric, and what is the process?
Oh yeah, so what Dilma and Suzanne, they were actually a graduate of this program
Last year.
and so because the Global Center for Success, our organization, is actually the parent of the Palayo People's Garden, and our goal, of course, to educate the community with healthy nutrition, organic gardening, empowering them to become self-sufficient. So when Vilma had this, we wanted to make sure to bring people in the garden, which is fresh air. And of course, that's what we're promoting, right? Instead of having the presentation in buildings, it's good to have it outside, fresh air. But the problem is when we're doing the PowerPoint presentation, it's very challenging because, electricity, it's hard to see. So we've done everything we can, put tarps and stuff like that. It was so cumbersome. So I decided that, you know what, why don't we do something where we don't have to use the PowerPoint and yet it's a good presentation. So we did the material. So, and it's expensive over here, we've been checking on that. But this team of ours went to the Philippines and had them printed there because it's much cheaper. So this is what we have. So, and we're gonna continue doing that. So we will be starting doing the presentation. I believe we have a schedule like towards the end of April, because March is here. So we were going to test that, and we're excited about it.
Thank you. Thank
I
you.
get a picture, I get a picture of you guys, one of the slides is fine.
So we were gonna mount it. I already talked to somebody to mount it, so that's easy to fit.
Raincoats, oh yeah. PFAS is all of lots of other things. VOCs, they can off-gas, so anywhere else you might find PFAS.
Probably in the fish, but.
Oh, did we not put it through yet? Oh, we did! Yes! Okay, we added it, okay. That's swordfish, yeah, there's other things, like we talked about stain resistance, anything else that you hear that might be
The car material, yeah.
Oh boy, honestly, yeah, PFAS, car, PFAS.
The mattress.
The mattress, where's the mattress though? Yeah. PFAS, yep.
Well, you get all the candy.
Yay!
Winner!
Charm Pops, Tootsie Pops, or regular?
Forever. Thank you.
So this one I had a question about. Oh yeah, oh you want to
There's a
Population had a high population of cats. So was like the second region? Is that what it was?
Yes.
Oh,
But it's
I
like.
think it, well, you, while you're reading our.
Yeah, they're great. I'm only halfway done.
Oh, okay, great. I'm so glad. We read a giant report, but that's like a, distillation of that. When we look at cadmium, I have a fact sheet, my cheat sheet here. Cadmium, definitely like smokers, we have concerns that they can have more cadmium, and then.
20% higher.